Today we're going to finish up our sampling distribution conversation, Chapter 7, by talking about the central limit theorem, a really important theorem for sampling distributions of sample means. Okay, it deals with normality. Normally, if our sampling distribution is taken from a population that is not normal, then there's not much that we can do with it. We can't use our z-scores or anything like that. So luckily, the central limit theorem helps us out. What the central limit theorem says is that if n, which is our sample size, is large, the sampling distribution of x bar, which is the sample mean, is approximately normal. Okay, remember again, this is called the central limit theorem, and it is only works for sample means, only works for the sampling distribution of x bar. Okay, remember that if we're talking about the sampling distribution of p hat, then we have to check the normal condition that n times p is greater than or equal to 10 and that n times 1 minus p is greater than or equal to 10. Okay, now many people say, alright, how do you determine if n is large? Well, in real life, it depends on the size of the population, the extent to which the distribution is skewed, on many, many things. For us and for the AP exam, we try and make it easy by giving you a exact thing to follow. And what we're going to say is n is large if n is greater than or equal to 30. So if your sample size is greater than or equal to 30, then you can use normal approximation on your sampling distribution of your sample mean, no matter what type of population it came from. So let's look at an example. Suppose that the number of texts sent during a typical day by a randomly selected high school student follows a right-skewed distribution with a mean of 15 and a standard deviation of 35. Assume that the students at your school are typical texters. How likely is it that a random sample of 50 students will have sent more than a total of 1,000 texts in the last 24 hours? Okay, when I see that I'm dealing with how likely is it that a random sample, that tells me I'm dealing with sampling distributions. Okay, so the first thing I want to do is state my question. What is the probability that a random sample of 50 high school students sent more than 1,000 texts in a day. Okay, notice that my only options for sampling distributions are p hat and x bar. Neither one of these talks about total. But if I take the fact that this is a total of 1,000 texts over 50 students, I can find an average. And that gives me 20. So basically, I'm looking for x bar to be greater than or equal to 20. And if x bar is greater than or equal to 20, then that means more than 1,000 texts were sent in the day. So let's plan. If I'm dealing with X bar, then the first thing I need to know is that X bar is normal. The sampling distribution of X bar is normal, else I won't be able to do anything. So we look up here at our sample size of 50 and we say, okay, 50 is greater than or equal to 30, so we can assume the sampling distribution is approximately normal. Okay, so once we decide it's normal, we need a mean. So the mean of X bar is just the mean of the population, which is 15. And we need a standard deviation. So standard deviation of X bar would be the standard deviation divided by the square root of the sample size. Okay. If I'm a table A kind of person, I need to go ahead and figure this out. If I'm a calculator kind of person, I can just leave it as it is right here. But what I do need to say is that we can assume there are more than 50 times 10, because this is the 10% condition, 500 students in the population. It says that it's at our school is our population, and our school has more than 500 high school students in it, so that's a safe assumption. So then we go to the do. I'm looking for the probability that X bar is greater than 20. So then I draw my normal curve. My mean is 15, so 20 would be right around in here. And I'm looking for greater than that. I do my z-score. 20 minus 15 divided by 35 divided by the square root of 50. And then if I'm a table A person, I need to calculate that z-score. But if I'm a calculator person, then I can just type all this into the calculator and not have to do all the steps along the way. And remember to type it into the calculator once it loads. I tell it to do norm CDF. My lower bound would be 20. My upper bound would be a really big number. My mean is 15. And my standard deviation is 35 divided by the square root of 50. And that tells me that my probability is 0.1562. So this is 0.1562. So I conclude there is about a 16% chance that a random sample of 50 high school students will send more than 1,000 texts in Uh,